The lights from Proxima Centauri b. The James Webb Space Telescope has made a discovery that could change everything we thought we knew about the universe. It has detected mysterious beams of light that appear to radiate from what seems to be a concentrated source like an urban center shining across the darkness of space. These lights are not natural starlight. They look like something artificial, something engineered. And they're coming from a planet light years away from Earth. This finding has reignited global interest in the search for extraterrestrial life. For the scientific community, it marks a thrilling and potentially historic turning point. The focus of this discovery is a planet known as Proxima Centauri b. It's the closest known exoplanet outside our solar system, orbiting the star Proxima Centauri, just over 4 light-years away. The James Webb Telescope observed strange, brilliant flashes of light originating from this planet's surface. These lights were irregular but consistent, suggesting something more than natural geological or atmospheric activity. Could this be the first credible sign of a technological civilization beyond Earth? For decades, people around the world from professional scientists to everyday dreamers have wondered, are we alone in the universe? They have scanned the skies, built powerful instruments, and listened to the stars, hoping for a clue. Now, this discovery might be the most promising clue yet. The telescope detected what appeared to be city-like lights, artificial, deliberate, and possibly constructed. It raises a stunning question. Is there an intelligent civilization on Proxima Centauri b creating visible infrastructure? The excitement this has caused within the scientific community is unprecedented. Some believe this may be the long-anticipated breakthrough that could reshape how we view life in the cosmos. At a distance of more than 4 light-years, these lights have left NASA engineers and astronomers in awe. Many now wonder, how long have these lights been shining? Were they always there, patiently glowing in the cosmic darkness, waiting for us to build the right tools to detect them? Dr. David Kipping, an astronomer at Columbia University, emphasized how unusual Proxima Centauri b is. Unlike most rocky exoplanets that passively absorb sunlight and re-emit it as heat, this planet behaves differently. Its relationship with its star appears far more complex and dynamic. This complexity might hold the key to understanding the source of those strange lights. Thanks to JWST's unmatched sensitivity to infrared wavelengths, scientists were able to pick up signals that other telescopes would likely miss. Where other instruments see only blackness, JWST detects subtle warmth, faint reflections, and spectral fingerprints. It excels at observing extremely faint sources of light, making it ideal for searching for artificial illumination in the dark expanses of space. The telescope can even distinguish artificial light from starlight. Artificial light tends to occur within a narrower band of wavelengths than natural light from stars. This distinction is how JWST identified that the glimmers from Proxima Centauri b might not be natural after all. The planet's environment is just as intriguing. Like many exoplanets, Proxima Centauri b experiences intense energy from its host star. It undergoes cycles of daylight and darkness, much like Earth, but the temperature range is far more extreme. If the planet lacks an atmosphere, its surface may be boiling hot on one side and freezing cold on the other. Such a dramatic thermal contrast is exactly the kind of thing scientists are looking for. It helps determine whether an atmosphere exists and what it might be made of. JWST is capable of detecting heat radiation from such planets. That's how scientists can tell which side is warmer, and whether any atmospheric buffer is present. Its observations give researchers an idea of how heat is distributed and whether life could theoretically exist. Even more interestingly, Proxima Centauri b completes one full orbit around its star every 11.2 Earth days. This relatively short orbit means the telescope can observe both day and night sides multiple times in a short period. Such frequent observations allow scientists to gather data on the planet's climate, light patterns, and energy flows. If Proxima Centauri b has an atmosphere, the next step is to analyze what it's made of. Researchers are now looking for chemical signatures, indicators that the planet might be habitable. Substances like water vapor, carbon dioxide, methane, or ozone could all point toward potential life-supporting conditions. Although JWST has some limitations such as its difficulty detecting free oxygen, it excels at identifying other important molecules. In particular, it can measure levels of methane and water vapor with incredible precision. The discovery of these gases in certain combinations might not prove the presence of life, but it would make a powerful case. Combined with the detection of artificial lights, unlocking the secrets of alien worlds even with its advanced capabilities, the James Webb Space Telescope cannot observe every planet in the universe. Its reach is limited to exoplanets relatively close to Earth. For that reason, astronomers are looking ahead to a new generation of observatories. One of the most anticipated is the Extremely Large Telescope, ELT, which is set to begin operations in 2028. This next-gen ground-based telescope will provide more detailed observations of exoplanet atmospheres. It will help researchers analyze temperature profiles, cloud formations, and even trace chemical compositions with greater clarity. Another major hurdle in space observation is starlight. Stars are incredibly bright, so bright that they overwhelm the dim reflected light from surrounding planets. To overcome this, scientists are creating tools that block or filter out starlight. One such tool is the coronagraph, which sits inside the telescope and blocks a star's direct light while letting in light from orbiting planets. Another is the Starshade, a giant flower-shaped spacecraft that flies tens of thousands of kilometers in front of the telescope. It blocks starlight before it even reaches the telescope's lens, revealing the faint glow of distant planets. These technologies are crucial to discovering and understanding planets in the habitable zone, a region around a star where conditions are just right for liquid water to exist. Water, as we know, is one of the essential ingredients for life. Yet, engineering such tools is no easy task. Starshades must maintain near-perfect alignment across vast distances. They must also survive the harsh environment of space and operate with limited energy. Despite the challenges, these efforts could lead to monumental discoveries. If scientists can block out starlight effectively, they will be able to detect faint biosignatures, chemical markers such as oxygen, methane, or carbon-based molecules that hint at biological processes. Researchers are also working on direct imaging, a method of capturing actual photos of exoplanets. With new technologies like adaptive optics, which correct distortions in real time, they hope to produce sharp, high-resolution images of planets orbiting other stars. These images could reveal more than just a planet's presence. We could see surface features, oceans, mountains, continents, or even cloud systems. In the best-case scenario, we might even detect artificial structures. Proxima Centauri b, due to its proximity and position within the habitable zone, is a top candidate. It may have the right conditions for water, and possibly even for life. But it might also be tidally locked, with one side always facing its star and the other side forever in shadow. This creates severe climate variations that challenge habitability. Still, if it has a thick enough atmosphere, these temperature extremes might be balanced out. JWST continues to monitor this planet and others like it, looking for any signs of life supporting chemistry. Its ability to detect tiny changes in atmospheric content gives astronomers a powerful new tool. The detection of gases like methane and carbon dioxide in the right balance could be a turning point. It may lead to the first credible proof that life exists beyond Earth. In the future, even more advanced telescopes will join the search. Some will be space-based, while others will be massive installations on Earth. Together, they will push the boundaries of what we can observe, analyze, and understand. The ultimate goal remains the same: to answer the most profound question humanity has ever asked: are we alone in the universe? The discovery of strange lights on Proxima Centauri b may be just the beginning. It could mark the start of a new era of cosmic exploration. As we continue to gather data, expand our tools, and deepen our curiosity, we move closer to uncovering the truth about our place in the cosmos. The universe is vast, and its secrets are many. But for the first time in history,